Power estimator software has pros which include the ability to estimate power requirements for electrical systems, accurately predict energy consumption, identify potential overloading issues, generate reports for documentation and review, and compliance with industry standards such as the National Electrical Code or International Electrotechnical Commission standards. Cons of the power estimator include complex calculations that can be time-consuming, a requirement for accurate input data for reliable estimates, and the potential unsuitability for specialized or high-complexity electrical systems. T&M billing software pros include the ability to track time and materials used for project billing, automate invoicing and payment processing, improve billing accuracy and efficiency, generate detailed reports for client review, and reduce administrative overhead. Cons of T&M billing software include the potential requirement for manual data entry which can be prone to errors, complex billing calculations which can be challenging to manage, and a requirement for integration with other software systems such as accounting software for full functionality. Overall, the power estimator and T&M billing software offer valuable tools for estimating electrical power requirements and managing time and materials billing. However, it's important to note that the software's effectiveness depends on the accuracy of input data and the complexity of the projects being estimated or billed. Additional considerations include price, the cost of the software, and any additional support or maintenance fees. Features include ensuring that the software meets specific requirements, such as support for different industries or project types. Ease of use includes making sure the software should have an intuitive user interface and minimal learning curve. Integration includes considering how the software will integrate with existing systems and workflows. Customer support includes evaluating the availability and responsiveness of customer support in case of any issues or questions. It's recommended to request a demo or trial version of the software before purchasing to assess its suitability for specific needs. When evaluating a power estimator, consider the following in more detail. Firstly, its ability to accurately predict power demands under various operating conditions. This involves understanding the types of loads the system will handle, such as resistive, inductive, or capacitive loads, and how these loads vary over time. The software should be able to model different scenarios, including peak demand, average demand, and standby power consumption. Secondly, its adherence to industry standards like the National Electrical Code, or NEC, and the International Electrotechnical Commission, or IEC. These standards provide guidelines for safe and efficient electrical installations, and the software should incorporate these guidelines to ensure compliance. This includes calculating conductor sizes, overcurrent protection, and grounding requirements according to the relevant codes. Thirdly, its capability to identify potential overloading issues. Overloading can lead to overheating, equipment damage, and even electrical fires. The software should be able to analyze the system's capacity and identify any points where the load exceeds the allowable limits. This may involve simulating different load scenarios and identifying bottlenecks in the system. Fourthly, its reporting capabilities. The software should be able to generate detailed reports that document the power requirements of the system. These reports should include information such as the total connected load, the maximum demand, the diversity factor, and the load factor. The report should also include a breakdown of the power requirements for different components of the system, such as lighting, HVAC, and equipment. Fifthly, the complexity of the calculations involved. While accurate estimates are essential, the software should also be user-friendly and efficient. Complex calculations can be time-consuming and may require specialized knowledge. The software should simplify these calculations as much as possible while still providing accurate results. Sixthly, the accuracy of the input data. The accuracy of the power estimates depends on the accuracy of the input data. The software should provide clear guidelines for collecting and entering this data. This may involve measuring the power consumption of different devices, consulting manufacturer specifications, or using industry standard values. Seventhly, the suitability for specialized or high complexity electrical systems. Some electrical systems, such as those in data centers or industrial plants, may have unique requirements that are not adequately addressed by general-purpose power estimation software. The software should be able to handle these specialized requirements, or it may be necessary to use a more specialized tool. When evaluating a time and materials, or T&M, billing system, consider the following in more detail. Firstly, its ability to track time and materials accurately. This involves recording the time spent on each task as well as the materials used. The software should provide tools for tracking this information in real time, such as time clocks and barcode scanners. The software should also be able to integrate with other systems, such as inventory management and project management software, to ensure that all relevant information is captured. Secondly, its ability to automate invoicing and payment processing. This involves generating invoices automatically based on the tracked time and materials. The software should be able to customize invoices to meet the specific requirements of each client. The software should also be able to process payments electronically, such as through credit cards or bank transfers. Thirdly, its ability to improve billing accuracy and efficiency. This involves reducing the risk of errors in the billing process. The software should provide tools for verifying the accuracy of the tracked time and materials, as well as for auditing the invoices. The software should also be able to streamline the billing process, reducing the time and effort required to generate and send invoices. Fourthly, its ability to generate detailed reports for client review. These reports should provide a breakdown of the time and materials used on each project. The report should be easy to understand and should provide the client with a clear picture of the work that was performed. The report should also be customizable to meet the specific needs of each client. Fifthly, its ability to reduce administrative overhead. This involves automating many of the manual tasks associated with billing, such as generating invoices, sending reminders, and processing payment. The software should free up administrative staff to focus on other tasks, such as customer service and business development. Sixthly, the potential for manual data entry. Manual data entry can be prone to errors. The software should minimize the need for manual data entry by integrating with other systems and by providing tools for automating the data entry process. Seventhly, the complexity of the billing calculations. Complex billing calculations can be challenging to manage. The software should simplify these calculations as much as possible, while still providing accurate results. The software should also be able to handle different billing methods, such as hourly rates, fixed fees, and cost-plus pricing. Eighthly, the integration with other software systems. The T&M billing system should be able to integrate with other software systems, such as accounting software, project management software, and customer relationship management, or CRM, software. This integration will ensure that all relevant information is shared between systems, reducing the risk of errors and improving efficiency. In addition to these specific considerations, there are also some general factors to consider when evaluating any software system. These factors include the cost of the software, the ease of use, the level of customer support, and the availability of training. The cost of the software should be considered in the context of the benefits it provides. The software should be easy to use, with a clear and intuitive interface. The vendor should provide adequate customer support and training to ensure that users can get the most out of the software. The National Electrical Code, or NEC, is a widely adopted standard for safe electrical installations. Several articles within the NEC are particularly relevant to power estimation and system design. Article 220 addresses branch circuit, feeder, and service calculations, providing methods for determining the minimum size of conductors and overcurrent protection devices based on the connected loads. This article covers various types of loads, including lighting, appliances, motors, and HVAC equipment, and provides specific calculation methods for each type. Article 220.12 specifically deals with general lighting loads, specifying the minimum lighting load requirements for different types of occupancies. This section provides guidelines for calculating the lighting load based on the area of the building and the type of occupancy. Article 220.14 provides requirements for receptacle outlets, specifying the minimum load to be considered for each receptacle outlet. This section also covers specific requirements for receptacle outlets in dwelling units, such as the requirement for ground fault circuit interrupter, or GFCI, protection in certain locations. Article 220.18 addresses motor loads, providing methods for calculating the minimum size of conductors and overcurrent protection devices for motors. This section takes into account the motor's horsepower rating, voltage, and full load current, as well as the starting current and duty cycle. Article 220.42 covers demand factors, which are used to reduce the calculated load based on the likelihood that not all loads will be operating simultaneously. This section provides demand factors for different types of occupancies and loads, allowing for a more accurate estimation of the actual power demand. Article 250 addresses grounding and bonding, providing requirements for ensuring a safe and effective grounding system. This article covers various aspects of grounding, including the grounding electrode system, equipment grounding conductors, and bonding jumpers. Article 310 covers conductors for general wiring, providing requirements for the selection and installation of conductors. This article specifies the allowable ampacities of conductors based on their size, insulation type, and installation conditions. Table 310.15b16 provides the allowable ampacities of insulated conductors rated up to 2000 volts based on the conductor size and insulation temperature rating. Article 430 addresses motors, motor circuits, and controllers, providing requirements for the installation and protection of motors. This article covers various aspects of motor installations, including motor overload protection, short-circuit protection, and control circuits. These NEC articles provide essential guidelines for power estimation and system design, ensuring that electrical installations are safe, efficient, and compliant with industry standards. Power estimation software often incorporates these NEC requirements to automate the calculation process and ensure compliance. Understanding these NEC articles is crucial for electrical engineers and contractors involved in power system design and installation. In addition to the NEC, the International Electrotechnical Commission, or IEC, publishes a series of standards for electrical installations. IEC 60364 provides requirements for electrical installations in buildings, covering various aspects of electrical safety and performance. IEC 61000 addresses electromagnetic compatibility, or EMC, ensuring that electrical equipment does not interfere with other equipment or systems. IEC 61508 addresses functional safety, providing requirements for safety-related electrical, electronic, and programmable electronic systems. These IEC standards are widely adopted in many countries and provide a comprehensive framework for electrical installations. Power estimation software may also incorporate these IEC standards to support international projects. When selecting power estimation and T&M billing software, it is important to consider the specific needs of your organization. Evaluate the software's features, ease of use, integration capabilities, and customer support to ensure that it meets your requirements. Request a demo or trial version of the software to test its functionality and assess its suitability for your specific projects. Remember that accurate input data is crucial for reliable estimates and billing. Invest time in collecting and verifying the data used by the software to ensure the accuracy of the results. Also, stay up to date with the latest industry standards and regulations to ensure that your electrical installations are safe, efficient, and compliant. NEC Article 210 covers branch circuits. It outlines the requirements for installing branch circuits, which are the circuits that supply power directly to electrical devices and equipment. This article covers topics such as the number of outlets allowed on a circuit, the types of conductors that can be used, and the overcurrent protection requirements. NEC Article 215 focuses on feeders. It provides guidelines for installing feeders, which are the circuits that supply power from the service equipment to the branch circuits. This article covers topics such as the minimum size of feeder conductors, the overcurrent protection requirements, and the voltage drop limitations. NEC Article 230 deals with services. It sets forth the requirements for installing service conductors, which are the conductors that bring power from the utility company to the building. This article covers topics such as the location of the service equipment, the grounding requirements, and the overcurrent protection requirements. NEC Article 240 is about overcurrent protection. It specifies the requirements for overcurrent protection devices, such as circuit breakers and fuses. This article covers topics such as the types of overcurrent protection devices that can be used, the ratings of the devices, and the location of the devices. NEC Article 250 discusses grounding and bonding. It provides guidelines for grounding and bonding electrical systems. Grounding is the process of connecting electrical equipment to the earth, which helps to prevent electric shock. Bonding is the process of connecting different metal parts of an electrical system together, which helps to create a low impedance path for fault current. NEC Article 300 covers wiring methods. It specifies the requirements for installing electrical wiring. This article covers topics such as the types of wiring methods that can be used, the installation of cables and raceways, and the support requirements for wiring. NEC Article 310 focuses on conductors for general wiring. It provides guidelines for selecting and installing conductors for electrical wiring. This article covers topics such as the ampacity of conductors, the temperature ratings of conductors, and the dating of conductors for ambient temperature and grouping. NEC Article 400 deals with flexible cords and cables. It specifies the requirements for using flexible cords and cables in electrical systems. This article covers topics such as the types of flexible cords and cables that can be used, the ampacity of the cords and cables, and the uses permitted and not permitted for flexible cords and cables. NEC Article 430 discusses motors, motor circuits, and controllers. It sets forth the requirements for installing motors, motor circuits, and motor controllers. This article covers topics such as the overload protection requirements for motors, the short circuit protection requirements for motors, and the control circuit requirements for motors. Knowing the software is compliant with these different NEC articles is something to keep in mind, and how it does so.